Hello students, welcome to a new session. In this session we'll be learning about the equality of the two areas of parallelograms. Let's go to theorem number 1. Surfaces of two parallelograms with common base and between two parallel straight lines, one is carrying this base, are equal in area. Corollary number 1. The parallelogram and the rectangle with common base and between two parallel straight lines are equal in area. Corollary number 2 says the area of the parallelogram equals the length of the base multiplied by its corresponding height. Let's see this very important remark. In the opposite figure, if ABCD is a parallelogram, where DF is the corresponding height of the base BC and DE is the corresponding height of base AB, then the area of the parallelogram ABCD equals BC times DF, which is the same as AB times DE. L1 times H1 is the same as L2 times H2. Let's now move on to corollary number 3. The parallelograms with bases equal in length and lying on a straight line, while the opposite sides to these bases are on another straight line, are also equal in area. We can deduce that from the opposite figure as shows. Since the straight line L is parallel to the straight line M, therefore, AK equals YN, which we're going to call it H. Therefore, the area of parallelogram ABCD is equal to BC multiplied by H. And also, the area of the parallelogram EFXY is equal to FX times H. If BC is equal to FX, then the area of the parallelogram ABCD is equal to the area of the parallelogram EFXY. Let's now go to exercise number 1. Choose the correct answer of the following questions. If the base length of the parallelogram is 7 centimeters and the corresponding height is 4 centimeters, then what is the area? As we said while we were explaining this part, that the area of the parallelogram is the base multiplied by its corresponding height. So here, the area is 7 multiplied by 4, which is 28. Question 2. If the area of the parallelogram is 50 centimeters squared and its base is 10, then the corresponding height of this base is equal to what? We know that the area, which is 50, equals the base multiplied by the height, so the height in this case is equal to 5. If ABCD is a parallelogram in which AB is 5 centimeters and BC is 10 centimeters, and its smaller height is 4 centimeters, then what is its greater height? So, we know that the smaller base multiplied by the greater height is equal to the greater base multiplied by the smaller height. So, in this case, 5h equals to 40, then h is equal to 8 centimeters. Let's now go to exercise number 2. In the opposite figure, ABCD is a parallelogram in which the measure of angle ABC is 150 degrees and AD equals to 12 centimeters, where AB equals to 8 centimeters, and E belongs to CB ray and AE is perpendicular to CB. Find the area of the parallelogram ABCD. Since angle ABC is 150 degrees, then the measure of angle ABE is 180 minus 150, which is 30 degrees. Therefore, since triangle ABE is right at angle E, therefore AE is half AB, which is 4 centimeters, because it's the side opposite to the 30 degrees that is half the hypotenuse. So now we can easily find the area of ABCD equals the base multiplied by the corresponding height. So the area is 12, which is the base, multiplied by the corresponding height, which is 4. Then it's 48 centimeters squared. Exercise number 3. The question here wants me to find the area of the parallelogram ABCD. Since YX segment is the common base, therefore C belongs to BC. Therefore, the area of triangle YXC is equal to half the area of the parallelogram YXBC. And we're going to call this number 1. Since BC is the common side, since BC is the common base, where BC is parallel to AY, therefore the area of the parallelogram ABCD is equal to the area of the parallelogram XBCY. We're going to call this number 2. So now we can easily say that from 1 and 2, we can say that the area of triangle XCY is equal to half the area of the parallelogram ABCD. So XCY is given that it's 15. So 15 is half the area of ABCD. Therefore, the area of ABCD is double the 15, which is 30 centimeters squared. Let's now go to the evaluation part. And whenever we reach the evaluation part, when you see the question, pause the video, try to answer the question yourself. After that, play the video again to check your answer. In this question, the question wants me to prove 2 things. The first one, that AEFB is a parallelogram, and the second thing, that the area of ABCD is equal to the area of AEFB. Let's now go to the first part. Since AEBD is a parallelogram, therefore AE is parallel to DB, where F belongs to DB as given. Therefore BF is parallel to AE. So we can also say that AB, as given, is parallel to EF. Therefore, AEFB is a parallelogram. After we prove that AEFB is a parallelogram, now the second part, the question wants me to prove that the area. After we prove that AEFB is a parallelogram, the second part, the question here wants me to prove that the area of ABCD is equal to the area of AEFB. Since the area of AEBD is equal to the area of ABCD, because AD is a common base, where AD is parallel to CE, and also since the area of AEBD is equal to the area of AEFB, because AE is a common base, where AE is parallel to DF. Therefore, from what we said, the area of ABCD is equal to the area of AEFB. And this is what the question wants us to prove. Dear students, by finishing the evaluation part, we came to the end of our session. Thank you very much and wishing you a good luck.